Hi everyone, this is Matt from OpenBuilds. In this instructional video, we're going to show you how to wire up your WorkBee 1010. So this is going to be all inclusive. We're going to show you how to wire up your LED light ring, your micro limit switches. Everything is going to be configured into drag chain, so it's going to be nice and aesthetically pleasing. Of course, everything's going to be wired back to your BlackBox motion control system. So it's super exciting. We're going to be using this awesome controller on this machine. We're also going to be going over the software settings, so everything's going to be configured into your controller, and you're going to be running G-code at the end of this video. So stay tuned, follow along with the steps, and let's get started. Okay, so on this first step, we're going to go ahead and start off with our 4-conductor wires. So as you can see here, I have 4 sets of the 4-conductor wires, one being at 13 feet, one at 7 feet, and then we have 2 here at 3 feet. So the idea here is we're going to go ahead and connect these to each one of our motors. So we have our Z-axis, our X-axis, our Y1 and Y2. So first I want to start here on the left side. This is going to be our X-axis motor, and we're going to use our 7-foot 4-conductor wire. So let's go ahead and move over to the left side. And this is all, of course, if you're facing the back of the machine. So over here at the left side of the machine, you're going to see 2 of our connectors, which you can detach or reattach. And this is for the convenience of just adapting these wires based on the colors that we see here. Each motor has coil pairs, and they've already been paired off for your convenience. So what we need to do is loosen these pin connectors on top of this attached pin. And you'll see these inserts here. What we want to do is get these towards the bottom of this connector housing. So that's what you should see there. Next, we're going to go ahead and take our 7-foot cable. So again, this is our 4-conductor wire here. You'll see 4 wires. And we're simply going to match the colors that we see here on the opposite connector. So we have red, blue, green, and yellow. So I'm going to orient these in that exact order. Okay, once you have these inserted, go ahead and tighten down the connector. Alright, and that's what you should see. Make sure that each one of these wire colors do correspond. So we have red with red, blue with blue, green with green, yellow with yellow. That looks great. What I'm going to do is throw this wire towards the front of the machine. So next we're going to move to our 13-foot cable here, which is the longest cable of the 4. And we're going to attach this to our Z-axis, which is up top here. So let's go ahead and turn our attention to the top. Okay, so the same process for the Z-axis motor. We're going to loosen these pins first and then match up our colors and tighten them back down. Okay, just make sure that those colors do match. Red, blue, green, and yellow. Red, blue, green, and yellow. So next we have 2 of our 3-foot cables. Each one of these is going to be attached to a Y1 and a Y2. It doesn't matter which one because each one's the same size. So I'm going to start here on the left side and move to the right. Grabbing one of the 3-foot cables, let's move to the left side. Okay, so at the back left side of the machine here, you will see one of our Y-axis motors here. This will be considered our Y1. And once we go through and label these, it'll become more clear of which one is which. But right now, we're just going to connect these 3-foot cables to each one of these motors. So same process, we're going to loosen up our pin connectors and insert the wire in the order that we see at the top of our connector, red, blue, green, and yellow. Alright, just make sure that those colors do match. Red, blue, green, and yellow. Red, blue, green, and yellow. Alright, now let's move on to the next motor. So on the back right side of the machine, once again, we're going to loosen up our connector here for our Y2 motor and insert that 3-foot 4-conductor wire into this pin. Once again, just matching up those colors. It's that easy. Alright, double check the wire colors. So that completes the connection of our 4-conductor wires to our motors. So we're ready to move on to the next step. So on this next step, we're going to be assembling our micro limit switches as well as attaching our LED light ring to our router spindle mount. So what we need to do is go ahead and gather these parts that you see here. What I have is 2 3-conductor wires at 13 feet, 1 3-conductor wire at 7 feet, 1 2-conductor wire, my LED light ring, 3 micro limit switch kits, and you can see that I have 2 already assembled in this configuration. So with the screw heads on the outside of the front plate, and then of course this screw is going to bolt into the V slot. So 2 of those are in this configuration for how we're going to mount these for the X and Y axis. And then I have one broken out here that we're going to assemble together. This is for the Z axis, and it'll be configured a little bit differently than these 2. So let's get started first by assembling our Z axis micro limit switch. So grabbing the back plate here, which consists of the micro limit switch, you can see it's soldered to the PCB case, as well as your 3-pin connector. And then take the front plate and we're going to align it to the 2 holes that you see on the back plate, and then attach each one of your 2 and 3 self-threading screws. And what I like to do is start one first, and then bring in my second screw, and then tighten them both down. So that's what you should see so far. Next, I'm going to take my nylon spacer, slide it in between each plate, and then I'm going to rotate this to where the solder joints are facing me. And I'm going to run the screw, the M5 screw, through that nylon spacer, add the slot washer here, and drop in T-nut. And that's what you should see. So the screw head is with the solder joints. Unlike our other 2, they're configured a little bit differently. Okay, so now that we've completed that assembly, let's go ahead and move on to the right side of this Z-axis. I'm going to show you where we're going to place this Z-axis micro limit switch. So let's go ahead and turn our attention there. Okay, so bringing in our micro limit switch for our Z-axis, we're going to place it in this front track of the Z-axis C-beam. So I'm going to drop my T-nut in place there and tighten this down into position. And the idea here is to have interaction between your wheel, nylon hex nut, and the micro limit switch. So I'm just using the coupling to move this up. You can see I have interaction there. So let's go ahead and move on to our next placement. Okay, so next we're going to go ahead and place our X-axis micro limit switch. So grabbing one of the 2 that we've configured, I'm going to move to the left side of the X-axis C-beam, and we're going to find that position to mount this. Okay, so right next to this black angle corner connector, I'm going to go ahead and place this micro limit switch. And you can see that this plunger is going to interact with our X carriage. So as the X-axis moves to the left side of this machine, it'll interact with this micro limit switch. And this is all for the purpose of a homing cycle. So now that we have this one placed, let's go ahead and move on to our Y-axis micro limit switch. Okay, so taking our last micro limit switch here, this is going to be for the Y-axis. We're going to move to the right side of the machine, and let's go ahead and place this one. So at the front right side of the machine, I'm going to place this micro limit switch right before the 20x40. So the idea here is just to place it right in front of that extrusion, find a good position there, and go ahead and mount that into place. And once again, this micro limit switch is going to interact with the Y gantry plate. So as it moves forward, it will interact with this micro limit switch, indicating the signal for a homing cycle. Okay, so now that we have all of our micro limit switches placed, what we're going to do now is designate each wire. We have 3 conductor wire, which goes to our micro limit switches, and 2 of these are at the same length and one is at 7 feet. So this is going to be the shortest cable here, which is going to go to our Y-axis micro limit switch. The 213 we'll have for the Z as well as the X. So I'm going to grab one of the 13-foot cables, and let's move to the left side towards the X-axis micro limit switch. Okay, so over here at the X-axis micro limit switch, you'll see your 3-pin connector here. What I'm going to do is go ahead and disconnect that. I'm going to loosen each one of these pins and prep this for the insertion of our wires. So since this is 3 conductor wire, what we have is a ground, our V+, which is our positive. This is going to provide power to the micro limit switch's LED light. So when you hit this plunger, an LED light will provide that indication that it's been activated. So it's really nice. Then we have our signal, which is going to be the blue wire on the 3 conductor wire. So we need to orient these in this position here. So ground, positive, and signal. So with the pins facing upright here, we're going to orient our wires with black to the left, red in the center, and blue to the right. And then tighten down your pin connectors. Alright, just give those a tug. That looks good. And let's go ahead and connect that back into the micro limit switch. So once again, you should see black to the left, red in the center, blue to the right. Okay, next we're moving on to the Z-axis micro limit switch. Once again, we're going to loosen that pin on each one of these sections. And this cable will be 13 feet for the Z-axis micro limit switch. And once again, with the pins facing upright here, black to the left, red in the center, and blue to the right. Once you have those inserted, go ahead and tighten down your pins. All right, and plug this back in. I'm just going to take this excess wire and throw it towards the back. And on our next step, we will be labeling all these wires, so don't concern yourself with the mess. Okay, moving over here to the Y-axis micro limit switch. Same process, we're going to loosen each one of these pins and insert our wire in the order that I just mentioned, which is black to the left, red in the center, and blue to the right. Plug this back into the micro limit switch. Okay, so next we have our LED light ring, which we need to attach to our router spindle mount. So what I'm going to do is just go ahead and disconnect the router spindle mount, which it's only attached by drop-in T-nuts. So it's pretty simple. You just loosen these screws and it pulls right out. So flipping this upside down here, I'm going to pop off these two black angle corner connectors. And I'm going to place the LED light ring right on top here. And then taking the screws, the black angle corner connectors, I'm going to go ahead and mount this back into position. And one thing to pay attention to is you do want these black angle corner connectors flush against the back end of the router spindle mount. Alright, and if you remember from the mechanical portion, we have marks here indicating 2 inches above the Z-axis end plate, and that's where we're going to mount this router spindle mount. Alright, now that that's back into position, all we need to do is come here to the right side of LED light ring. We're going to disconnect this pin, and we're going to go ahead and connect our 2 conductor wire here, and then reattach that to the LED light ring. So loosening the 2 pins here on the 2-pin connector. We're going to go ahead and insert our wires with the pins facing upright. You should see black on the left and then positive on the right. And then tighten down those pins. And let's go ahead and reconnect this to the LED light ring. Alright, we're going to toss this wire towards the back, and that completes this step. So let's go ahead and move on to the next step. Alright, so on this next step, we're going to be labeling all of our wires. So what you need to gather is some painter's tape and a permanent marker. And what I'm going to do is focus on the point of origin for each wire. We have 4 conductor, 3 conductor, and 1 2 conductor for our LED light ring. So first, I'm going to focus on the Z-axis, which is up top here, and that's a 4 conductor wire. So locate it from the point of origin, trace it back, and you'll see that it is 4 conductor. Taking a piece of tape here. What I'm going to do is wrap it all the way around, and the reason for doing so is I do not want this to snag on the drag chain. So once we get to the installation of the drag chain, all these wires are going to be fed through. So if you were to create a flag on these, it would rip. So we just want to keep it all the way around the wires. And this is the Z motor, so I'm going to label this ZM for Z motor. And let's move on to the next. I'm going to go ahead and grab the X motor, which is over here on the left side. Trace it from the point of origin, and you'll see it's a 4 conductor wire as well. And wrap that all the way around. And this will be XM for X motor. Okay, next I'm going to grab my Y-axis motor. So this is a Y1, and this is going to be on the left side of the machine if you're to face the back. And it's a 3-foot cable, so you won't have to go very far to find the end. Once again, this is a 4 conductor wire. I'm going to wrap it all the way around with my tape. And I'm going to label this one YM for Y motor. Next, moving to the right side if you're to face the back of the machine, this is going to be our Y2 motor. Once again, it's a 4 conductor wire. I'm going to label this one Y2M. So that completes the motors. Next, we need to move on to the micro limit switches. Starting here on the right side first, this is the X micro limit switch. So trace that from the point of origin, and this will be a 3-conductor wire. Same process, we're going to wrap that tape around. And for the micro limit switches, I'm going to label this one XML for X micro limit. Next, moving to the Z-axis micro limit switch, which is going to be right up front here. Once again, this will be a 3-conductor wire. All right, I'm going to label this one ZML for Z micro limit. Next, moving to the Y-axis micro limit switch, which is to the front left side of our machine. So trace that back to the point of origin, and I'm going to label this one YML for Y micro limit. Okay, and last but not least, we have our LED light ring, which is the only 2-conductor wire. It's also the longest wire at 18 feet. We're going to label this one LED. Alright, so now that we have all of our wires labeled, it's time to move on to the next step. Okay, so on this next step, we're going to be installing our X-axis drag chain here to our cable tray of our X-axis. So we need to go ahead and gather these parts here. We have a 1,000mm drag chain, one 250mm black slot cover, 1,000mm black slot cover, one M5 25mm screw, two M3 8mm screws, one 9mm aluminum spacer, one M5 T-nut, two M3 T-nuts, and a single L bracket. And of course, for the tooling, I'm going to use my ball drivers as well as some painter's tape. And to get started, first we need to loosen up some of the screws on the side gantry plate so we can insert one of our M3 T-nuts. So let's turn our attention to the left side of the machine if you're to face the back. Okay, over here at the left side, we're going to loosen up these 2 screws that are holding the 20x40 rail in place. So this is kind of like the cable tray here. It's going to hold our drag chain in place. And just slide this out of place here. And taking one of the M3 T-nuts, I'm going to go ahead and slide this into the track of the 20x40. And I'm going to push this back into place. So next we need to go ahead and install our single L bracket here to our X carriage plate. So I'm going to grab the single L bracket, making sure that I do have this oriented correctly. Check for the corner edge of the single L bracket. We're going to use the hole spacing that's closest to that edge to mount to our X carriage plate. So take the 25mm screw. We're going to run that through the hole of the single L bracket and add the 9mm aluminum spacer. We're going to place that right here into the center hole of the X carriage plate. From there, we're going to go ahead and add our M5 T-nut to the back end of the screw, and we're going to mount that into place. So what I like to do is position this single L bracket to where it's facing down, and that way we'll mount our drag chain from right underneath. So next we're going to turn our attention here to the X-axis drag chain. And what I like to do is first understand the configuration in which this drag chain is going to be placed. So since we have 2 end caps, basically mirroring each other here, one is going to mount to the 20x40 with that M3 T-nut that we inserted. The other is going to mount to that single L bracket. So what we're looking for is a position like so. So this end cap is going to mount underneath the single L bracket with our M3 8mm screw, and this side is going to mount to the M3 T-nut in the 20x40. So what we need to do is take all of our wires that are going to be inserted into the X-axis drag chain, and we're going to insert it into this position. So everything's going to be fed through this section of the drag chain. So with that being said, we're going to locate all the wires that are going to be inserted into this drag chain. So what we have here is 3 wires. One's a Z-axis motor. We have Z-axis micro limit switch and our LED light ring. So these 3 wires are going to be fed through the drag chain, and once again that position is going to be underneath the single L bracket here. So what I'm going to do is locate the ends of each one of these wires. So once we've located the ends of the wires here, I'm going to take some of my painter's tape and I'm going to tape these together. That way it's easier to insert this into the drag chain and feed it through. So I'm going to go ahead and wrap this. And bringing the drag chain in once again, make sure you find the top side that we're going to feed the wires through, which is this side, and insert those wires into the drag chain. So what I like to do is pull some of the slack through, but on the opposite end of the drag chain here, I like to leave a little slack. That way we can run our slot cover into that 250 Z-axis C-beam, and we can run these wires to the back of our X carriage on the top. So leave some slack there. We'll go ahead and set the drag chain down. We're going to turn our attention to our 250 millimeter slot cover. We're going to come up here to the front of the Z-axis C-beam and mount those wires into place. So the idea here is to get these wires into this front track of the C-beam, and we have a 250 millimeter slot cover. So we need to cut this down to size. So generally what I'll do is place it in here, get a point of reference, and cut off the excess that'll fit in that slot. So now that I have it cut to size, I'm going to bring my wires into position here. Then I'm going to insert the slot cover. Okay, so now that we have the slot cover in place, I'm going to take the excess and run it off the back of the X carriage plate. So now that we have these wires in position, I'm going to go ahead and pull the additional slack through the drag chain here. Okay, so next I'm going to take the top end of this end cap and I'm going to mount it to the single L bracket using one of the M3 8mm screws. Come through the center hole of the end cap and through that single L bracket. What I do is just thread on that M3 T-nut. We're going to place that in position. And then from there you can take your ball driver and tighten this down. Alright, so now that that's mounted, on the left side here you'll see a square hole here in the Y gantry plate. We're going to feed those 3 wires through. So next here on the right side you'll see our X-axis micro-limit switch wire, which is a 3-conductor wire. What we need to do is insert that into the 20x40 V slot, and we're going to encase that with our slot cover. So taking this 1000mm slot cover here, I'm going to measure out what distance I need, and I'm going to cut off the excess about 2 inches exactly. And with the X micro-limit switch wire, I'm going to take additional length here and pull it from underneath the X-axis C-beam. And starting on the right side first, I'm going to go ahead and start inserting the slot cover. All you have to do is press into the track. And from there, I'm going to take my wire and run it through the bottom of this drag chain over here on the left side. So right underneath the drag chain, you'll see a slot. We're going to run that through. And then back through the square hole here where our additional wires ran through. Just kind of weave it on through the drag chain. Okay, so now we have that wire through the drag chain. I'm going to finish inserting the slot cover here to this 20x40. Okay, so now that our slot cover is inserted, let's go ahead and turn our attention to the left side. We're going to go ahead and mount the opposite end of the drag chain with our M3 8mm screw. And just like we did the opposite end, we're going to run through the center hole of the drag chain. Alright, make sure that's nice and tight. Now that we have our drag chain mounted, it's time to go ahead and move on to the next step. Okay, so on this next step, we're going to be assembling our Y-axis drag chain. So what I've got gathered here is the tools and the parts that I'm going to be using in this step. Starting with the Y-axis drag chain at 1000mm, 2 single L brackets, 1 end cap, 1 M5 15mm screw, 2 M3 8mm screws, an M5 T-nut, 2 M3 T-nuts, of course our slot cover here at 1000mm. Now aside from that, the tooling I'm going to be using is a power drill. I also have my ball driver set here and some painter's tape. So to get started, first let's go ahead and focus on our single L brackets, which is going to mount to the back of our machine. So let's go ahead and turn our attention towards the back side of the machine here. So here at the back side of the machine, you're going to see the end cap, which is connected by 2 self-tapping screws. So we're going to loosen each one of these screws. And just go ahead and put this end cap to the side for now. And bringing in one of my single L brackets, I'm going to focus on the spacing that's closest to the edge here, because that's going to be mounting to this bottom track of the 20x40. So reusing one of the self-tapping screws, I'm going to go ahead and mount this on that bottom slot of the 20x40. Alright, and once you have the single L bracket in place, taking the end cap with the other self-tapping screw, I'm going to go ahead and mount this to the top track of this 20x40. Okay, so next we're going to mount our last single L bracket onto our Y gantry plate. And the reason for doing so is we're going to once again mount our drag chain using these single L brackets. So I'm going to focus here on this top hole, and this is where I'm going to mount my single L bracket. So taking an M5 15mm screw here, I'm going to run it through once again that hole spacing that's closest to the edge, and run it through this hole. It's right underneath the nylon hex nut here. I'm taking one of the M5 T-nuts on the back side of the gantry plate. I'm going to go ahead and mount this bracket into place. Alright, next taking the Y-axis drag chain. Once again, we're going to go ahead and take a look at our end caps and see how they're going to mount to these single L brackets. So the top portion of the drag chain here is going to mount underneath the single L bracket, and then our additional side is going to go back to the single L bracket that's mounted at the back of our machine. So this top portion of the drag chain is going to receive all the wire. So what we need to do is locate all the ends of our wires, including our X motor. This will now be included with our additional wires, and we're going to run that through our drag chain. So we have two additional wires that are going to be taped to this bundle. So just like we did for the X-axis drag chain, we're going to take some painter's tape and we're going to bundle these wires together. Now taking the drag chain, we're going to feed it through this top portion. Okay, so once you have all the wires ran through the drag chain here, we're going to go ahead and take one of the M3 8mm screws and run it through the center hole here of the end cap of the drag chain, and we're going to mount it to the single L bracket that's placed on our Y gantry plate. So go ahead and take an M3 T-nut and let's thread that into place. Okay, so now that we have this top portion of the drag chain mounted, let's go back to the back side of the machine and mount the additional portion. So mounting here on the left hole of the drag chain, go ahead and insert the M3 8mm screw, and from underneath the single L bracket we're going to mount our M3 T-nut. Now the best way to do this is just shift your machine off to the side of the table so you can have access, and then you can thread on your M3 T-nut. Okay, so that should be the end result here. See, we have our Y-axis drag chain mounted. Now the additional slack that's right here next to our X motor, we're going to go ahead and run some of that slack back through the drag chain. Okay, so next we need to focus on our 1000mm slot cover and our Y micro limit switch. So taking the 1000mm slot cover here, I'm going to place this on top of the Y limit switch wire and run this towards the back of the machine. And you'll notice the slot cover is a little bit long, so all you have to do is cut off that additional excess once you've found how long you want this to run. Okay, so now that we have our Y limit switch encased with the slot cover, we have a drag chain mounted, everything's looking really good. Let's go ahead and move on to the next step. Okay, so on this next step, we're going to be assembling our BlackBox motion control system as well as our power supply unit. So we have a 24-volt power supply. We also have all the components that are included within this kit. You see that I've already assembled my power case kit as well as the BlackBox. Each one of these requires an assembly, and I'll link those videos at the top. They're really quick, easy videos, say about 5 minutes per video for each assembly. And once you get those assembled, we'll go ahead and get started with the rest of the assembly, which is the connecting of our wires, configuring our power supply, as well as just getting everything set up and organized. So starting here first with the BlackBox, you'll see that we have additional components that are laid out. What I have is my male connectors, which are 4-pin connectors, as well as male 3-pin connectors. These all come attached to your BlackBox control board. So all I've done is detached each one, laid them out here for our convenience when attaching our wires to each connector. Also, we have our corrugated tubing that's included with the BlackBox, it's at 1 foot. Also have 2 M5 6mm screws, as well as 2 drop-in T-nuts. These are also included with the black box. Aside from that, we have an M5 8mm screw with a drop-in T-nut and a flex tubing clamp. This will be included in this kit. So this is for the aesthetics portion. We're going to mount our corrugated tubing on the back end of the machine. We also have the 24-volt power supply. Each one of these wires comes with the power supply. So we have our power cord as well as our power wire that provides power to our controller board. So let's get started first by attaching our wires to our 4-pin connectors. On the opposite side here of the black box, you'll see that we have our limit switches and our motor section here. So what we need to do is just go ahead and locate our labeled wires. So before we get started with connecting our wires, I want to go ahead and prepare the black box for mounting. So you see these holes on the side of the black box. This is our mounting configuration. So I'm going to use my M5 6mm screws. I'm going to run them in the bottom slot of each one of these holes on each side, and then thread on a drop-in T-nut. And that's what you should see there. So we have access to the power switch here, and it's going to mount to our 20x40 rail at the bottom. The reason for inserting those screws now is if we inserted one of our motor connectors, we wouldn't be able to get that screw in. So we're going to go ahead and do that in preparation. So next, let's go ahead and grab one of our 4-pin connectors, and I'm going to grab one of my motor wires. Doesn't matter which one. We have them all labeled. This is a Y motor, and also it's 4 conductors, so we know it's a motor. And like we did on previous steps, we're going to loosen each one of these pins. And taking our 4-conductor wire, we are going to insert these colored wires in this order. The pins facing up, red, blue, green, and yellow, working our way from left to right. And that's going to be consistent for all motors. So we're going to go ahead and insert this one first into the Y motor section as soon as we get these pins tightened down, and then we'll move forward to our following motors. All right, give those a tug, make sure that they're fully inserted. Once again, red, blue, green, and yellow, those are the ordered pairs. So on the input section here, the black box, you'll see an option for Y motor. We're going to go ahead and plug it in, and it's that easy. So we're going to continue on with the motors. Let's go ahead and get each one of those connected to our pins and plugged into our black box. So I've located my Z motor. Once again, same process. Loosen those pins. And the ordered pair is red, blue, green, and yellow, working our way from left to right with the pins facing upright. So this is our Z motor. Just plug that into the Z motor section. And let's get these last 2 motors done. Okay, so now that we have our motors complete, let's go ahead and move to the micro limit switches. So we have 3 of our 3-pin connectors. I'm going to go ahead and start by just loosening all those pins in preparation. So locating my first micro limit switch, this is my Y micro limit switch. So what we're going to do is take a look here of the orientation we need to set up for these wires. We have our ground positive signal, so that means left to right, black, red, and blue. So we're going to go ahead and insert those in that order, the pins facing upright. And we're going to do that for all 3 micro limit switches. So let's go ahead and get that done. Once again, all we're doing is matching up our labeled wires with the input here. You see Y limit. That was my Y limit switch, so I'm just plugging that in. And then let's move to our next micro limit switch. And this is the X micro limit switch, so I'm going to plug that into the X limit section. All right, let's move on to our last, which is the Z micro limit. All right, and that's what you should see. We have all of our micro limits and motors inserted into our controller. So let's go ahead and move on to the power supply unit. So with the power supply unit, one thing to pay attention to after you get the case assembled is your switch here on the side. These come factory with the 230 volt indicated here. We need to switch that to 115. So just go ahead and do that real quick. And aside from that, we have our power cord here. Just going to simply plug that into the front face of the power supply. This will provide power to the actual unit. Then taking the power cable here, plug that into the front section of the power supply unit once again. And then the opposite end is going to provide power to the black box, which you'll see the power supply unit indication here. I'm going to simply plug that in. And next what we have here is our LED light ring. So you have two options. You can either plug that into the power supply. You have enough length to where you can mount that at a separate place. Or you can do, what I'm going to do here is I'm going to connect this to my power supply unit plug here. And basically what I like to call a piggyback, I'm going to go ahead and wire this up because it's 24 volts. It's powered to the controller. So this can simply power my LED light ring as well. So I'm going to loosen up each one of these pin connectors. And I'm going to go ahead and wire this in. It's again black on the left. That's our ground, and then of course positives to the right, and then tighten down that pin connector. Just like so. And then once again we're just going to plug that into the black box here. So now whenever you turn on your power supply and your black box, power will be provided to your LED light ring as well. So now I'm just going to go ahead and move my power supply to the right of the machine here. So next I'm going to take my black box here. I'm going to configure this to the middle of the WorkBee here. So finding that position, I'm then going to mount the drop-in T-nuts at the bottom slot of the 20x40. So we're going to do that on both sides. Alright, now that that's mounted in place, so what I'm going to do now is orient these wires to where I can get some of this stuff organized. The idea here is one of the Y-axis motors is going to run to that right side. So I'm going to actually run that underneath the black box here. And later on we'll use zip ties to mount that next to the motor. And then of course for all of my additional wires, including the LED light ring here, I'm going to bundle these into that corrugated tubing that's given to us with the black box kit. Splitting this, you can see I can just open up and accept all the wires here. And that's pretty much the gist of it right there. I'm going to try to keep all these wires to where I can see the labels, just in case I want to configure something differently. And from there, I'm going to run my flex tubing clamp towards the left side of this corrugated tubing and mount that to the V slot. So taking the flex tubing clamp here, I'm going to find that mounting position and clamp it around the tubing here. And I'm going to take the 8mm screw and I'm going to lock this on with the drop-in T-nut. Okay, so now that we have our corrugated tubing locked into place, let's go ahead and move on to the next step. Okay, so on this next step, we're going to go ahead and gather our zip ties. We have 15 zip ties here, and I've got some snips. And basically what we're going to be doing is going around the machine and just tidying up all of our wires. So we want to make sure everything is nice and tight and just aesthetically pleasing. So first I'm going to start here with the end of the black box, our input section here for our motors and limit switches. And I'm going to go ahead and wrap one of these zip ties around this bundle of wire. Following that, I'm going to move here to the left side towards this bundle of wire that's at the end of the corrugated tubing. So grabbing two of my zip ties here, I'm going to create one large zip tie so I can bundle these wires together. And what I'm going to do is strap it to this corrugated tubing. That way it's kind of like one unit. Snip off the excess. And I'm going to do it in two more spots. I'm going to do one here on the right side and one on the left. Okay, once again on the left side here. Okay, so what you're left with is this bundle of wire here. So next I'm going to go underneath this flex tubing here. And once again, taking two zip ties, I'm going to secure it in two spots. Okay, so after completing the one zip tie here, I actually feel like that's pretty sturdy. So I'm going to leave it as is. And I'm going to move here to the left side. And I'm looking for this motor connector. Underneath here, you'll see your motor connector. And what I'm going to do is use one of my zip ties, run it through each sets of wires on the male and female connector, and create a strong connection between the two. That way I don't have to worry about the system unplugging. Alright, and once you have those zip tied, see that that's a solid connection there. Next, over here on the left side of this motor, just going to come in with another zip tie and secure these wires together in a bundle. And next I'm going to move to each one of the connectors. So we have X-axis motor connector, Z, and we also have the Y2. So we're going to move to each motor and zip tie each connector. So over here at the Y2 motor, what I'm going to do is use some of my remaining slot covers, the pieces that I cut off my 250 and 1000 millimeter. And I'm actually going to just slide these into the 20 by 40 here to contain this wire. And with the additional slack, I'm going to create a bundle, and I'm going to zip tie this connector to this 40 millimeter aluminum spacer. Okay, so now moving our attention back to the Z-axis motor, I'm going to come in here with some zip ties and bundle these wires together. You have 3 wires. Alright, so that completes the wire organization portion. So let's go ahead and move on to the next step. Okay, for this next step, we just need to install our USB cable to our laptop and controller. So what I have here is our standard serial port connection. So obviously this end here is going to attach to the laptop and the USB port section. And then the serial port we're going to attach to our black box on the right side. So right here is our port connection. Go ahead and plug that in. So now that we have our USB connection established, let's go ahead and move on to the software portion. Okay, so starting the software portion, the first thing we need to do is open up our browser, and let's go to OpenBuilds.com. Once you've reached OpenBuilds.com, you'll see that we have tabs here listed on the forum. We're looking for the software tab. Let's go ahead and select that and open up the OpenBuilds control machine driver. Next, we're going to go ahead and download this executable. I'm using Windows, so I'm going to go ahead and download for Windows. If you're using Mac or Linux, you can choose those options and then download. From there, go ahead and save the file to whichever location you choose. Once the download is complete, you'll see here a couple prompts will pull up. We're going to run through those and go ahead and set a file destination for this controller and install. And once it's installed, you'll get a notification here showing that the control has started. So we're going to go ahead and open up the OpenBuilds control software. Okay, so now that the OpenBuilds control software is open, first thing we're going to take notice to is our COM positions here. We're looking for the FTDI USB to serial. So this is a COM4. It will be different on your laptop or whichever device you're controlling your machine with, but make sure you do locate the FTDI drivers. So go ahead and connect. And the first thing you'll see initiate is your alarm state here. And this is just precautionary for any machine. When you're doing CNC work, especially, lead screw driven, belt driven machines, large profiles, you just really want to remain safe. So this is a nice feature that's included in the software that will continue to make sure that you're staying safe. So when you initialize your machine, this is going to activate. So all you have to do is hit unlock alarm. We don't have any power provided to the machine currently because we're simply going to configure our Gerbil settings. So what we need to do is go up to this top tab, which is Gerbil settings. We're going to select this and we're going to load default settings. You can see here that I've already selected the WorkBee 1010 with limit switches installed. But in order to find that, you're going to select the drop-down menu, select OpenBuilds WorkBee, and then you have the different configurations. So we have the 1510, the 1050, and the 1010. So for this video, I'm working with the 1010, but this is identical to the WorkBee 1050 as far as lead screw driven, steps per millimeter. Now the profile of the machine is going to be slightly different since the configuration is different. So if you have the 1050, you'd select that. If you have the 1010, you're going to select the WorkBee 1010. So go ahead and select that, and you'll see it populate here into your default settings. In the top left corner, you'll see an option to save to firmware. Go ahead and select that, and it'll save in a couple seconds. So once that's complete, the really cool thing about these default settings is everything is configured into your controller. So now you can start operating your machine based on the settings that we've tested and all the different values. So you can see I'm scrolling through advanced settings here. Now these can all be tweaked based on your preference or if you've modified your machine. So, don't think that you're stuck in this situation. This is just default settings to get you started. But these work great. I have to say, don't touch these right away if you're a new user. Just use these, get comfortable with your machine. Okay, so now that we have our default settings loaded, let's go back to the control tab here, and let's go ahead and power on our machine. Okay, so now that we have our machine powered on, the first thing you should hear is the motors activate, and you should also see that your LED light ring has activated. So you'll see that bright light coming from your LED light ring. So these are all signs and signals that your machine is powered on. So what we need to do from here is we're going to go ahead and test our machine, do a little bit of jogging, go over some of the features of the software, and then after that we're going to run some G-code. And these are all steps to take before you start your projects on your machine. You want to make sure everything's functioning correctly. You want to make sure everything's mechanically sound, as well as all your wiring. Obviously, you need to make sure that everything is moving in the right direction. So we're going to go ahead and start with our DROs, which is digital readouts. So what you see here is our box for X, Y, and Z. These are all coordinates that are indicated after the machine has been operated. So generally I always start with a 0 point here. Now when we make moves on our machine, we'll know exactly how far we're moving. So setting our machine to 1 millimeter increments here, we're going to start with the incremental jog, not the continuous jog. That way we know exactly how far we're going to be moving. A millimeter is very small, so we're going to go ahead and start there. So a Y positive movement is going to move our machine to the back towards our controller. Okay, so for a positive movement, back towards the controller. Negative movement is going to move your machine back towards the front. So let's go ahead and test that. So you can see that my y-axis is moving in the right direction. So I'm going to go ahead and select 10 millimeter increments here. And you can see that it is functioning flawlessly, which is awesome. I can move up to 100 millimeters. Give you an idea of how significant movement looks, and it looks great. So negative movement is going to bring that back. Once again, positive is going to bring it back towards the controller. Negative, back towards the front of the machine. So that looks great. Going back down to 1 millimeter increments, we're going to try a positive movement for the x-axis. And positive movement is going to move to the right. Negative movement is going to move to the left. So let's go ahead and test that. So it looks good. It's moving to the right here. I'm going to move that to 10 millimeter increments. It looks great. So 100 millimeter increments. You can see that everything looks good there. So negative movement should bring that right back to the left. That looks great. So next we're going to go ahead and test our z-axis. So a negative movement is going to move this axis down towards the material. Positive is going to bring it upright. So let's go ahead and test that at 1 millimeter increments. So you can see negative movement is down, positive is back up, and that looks great. So everything's functioning correctly here with our movements for X, Y, and Z. So let's go ahead and test out our micro limit switches. So before we run a homing cycle, we're going to go into the troubleshooting tab here and test our limits to make sure that we are getting a signal for each limit. So first I'm going to start here with the x-axis just to give you an example. So I'm going to select this, and the first thing you should see is your alarm state has been triggered. So we do have hard limits enabled. So anytime your machine touches a limit, it's going to stop the machine. So this is immediate halt. Rehoming is highly recommended. So if you're in the middle of a job and your limit switch is activated, I would rehome the machine to make sure everything is functioning correctly there. So we're going to go to cancel. We're going to leave the alarm state on. I'm going to show you how this pin interacts. So as I hit the X limit switch, you'll see it turn red, on, and then off. Now we're also going to do that for our Z-axis micro limit switch. You'll see that it turns on as well. And then of course our Y-axis micro limit switch. Okay, so everything is functioning correctly there. Our limits are sending the signal to our controller. So we're going to unlock our alarm, go back to the control tab. Okay, so now that we know our micro limit switches are functioning correctly, let's go ahead and start our homing cycle. Go ahead and select that. It's going to find the Z-axis first, which it should go upright, and then X and Y. Okay, so everything looks great there. Our micro limit switches are functioning correctly. Our machine is operating flawlessly. So let's go ahead and go over some of the features that the software has. So starting off here with the 3D Viewer tab, absolutely love this feature. You can see that you have your machine profile listed here as well. So if you ever have multiple machines in your shop, you'll always know which one is configured to which controller. Really convenient. And the 3D Viewer, you can manipulate, you can zoom in, you can change the orientation, which is really cool. You can also do a simulation. So based on what you're working on or what projects you have submitted to the controller, you'll see that populated here. And then of course you have your serial console tab here, which is going to display the coding information here sent to the machine. So you can see your Gerbil configuration is here, which is basically the same thing that we see in Gerbil settings. It's just simplified in Gerbil settings. This is kind of the raw code. But this is a great tool because if you have any issues, this is generally where you will see any type of problems, any type of error code. So definitely something to copy and paste and send to the forum so we can evaluate it and help you troubleshoot through your problems. Of course, you have macros as well, which is a really nice feature for those who want to set up specific waypoints and just configure your machine based on your preference. Of course, you have GCode Editor as well, so you can write custom code in here, which is really convenient. So other than that, we also have some really cool features here. We have millimeters mode, which generally I stay in. I prefer the metric system when working with CNC applications. You also have inch mode, which is convenient if that's something that you prefer. By all means, this option is available. Another cool feature is the continuous jog. If you select that and come in here to Wizards and Tools, you'll see that you have an option to customize your shortcut key assignments. So I generally stick with the default, pretty simple, save and apply, and from there you can control your machine with your keyboard. So it's just a really nice feature there. Also in Wizards and Tools, which is one of the main features here that you will probably be using, we have Surfacing Wizard, which is really cool. You can run through this, and of course the wizard is really helpful. You have your router bit diameter, step over feed rate, you have your width, length, and skim depth. So pretty much self-explanatory there. So based on your machine profile and your bit diameter, you can run the surfacing tool. So really cool stuff there. We also have the calibration wizard for a servo. If you're using a servo for like a drawbot application on your acro, you have your calibration for Z-axis, Y-axis, and X-axis if you're using a custom machine. You also have the mobile jog widget, which is really cool. You scan this QR code and you can control your machine with your mobile device. So that's a really cool option here. Also, you have the tool on feature. So if you're using an IoT relay, this is where you would control your spindle, your laser, or plasma. And of course, the off feature here. So you're going to turn that tool off. But this is all really cool, features that are included in the software. Other than that, we also have our go to zero function here. So basically when you set your 0 point, you have options to go to 0, so your work coordinates here, or you have machine coordinates. So depending on how you're operating your projects, these features will be extremely helpful. Other than that, we also have a really cool feature, which is a link directly to OpenBuilds, so you can always select this and communicate on the forum. Start a new thread for any issues that you might have, or just, want to communicate with other builders and engineers. Definitely a great place to communicate with like-minded people. So next to that, we have the troubleshooting tab, which I want to show you real quick. We already went over this briefly with the limit switches, but you also have your probe option here, a door sensor, and different buttons here. So these are all good ways to test these components before you start using them. You also have communications here, so you can understand, which version you have installed, connection status, all that good stuff, as well as a change log here to just give information on recent updates to the software. Also up at the top, we have the OpenBuilds forum. So if you have questions and you need support, this is where you would go. So go ahead and select this and you can communicate with the OpenBuilds engineers and start to troubleshoot any issues that you might have. Okay, so going back to the control tab here, that pretty much explains majority of the tools and applications here on the software. It's pretty much self-explanatory. It's very intuitive software. So if you have any questions or suggestions, definitely check out the forum and just reach out and tell us how much you like the software. So now we're going to go ahead and run some G-code. So what we need to do is go ahead and open up our OpenBuilds CAM GCode Generator, which is in our browser. So we're going to go ahead and select openbuilds.com. So down here at the bottom, you'll see an option for OpenBuilds CAM GCode Generator. We're going to go ahead and browse to. And what we're going to do next is go into our settings, and we need to select the configuration that we're using, which is the WorkBee 1010. So we're going to go in here to the defaults, open up WorkBee and the 1010 configuration. And of course, the controller that we're using is a BlackBox. A tool, it's going to be a router or a spindle. Obviously, we're doing an air cut to test out our machine, so you can just keep this turned on, it's fine. And then all of your customized defaults are going to be listed here, which is really nice. It's all default settings here. I'm going to go ahead and save that. And next you're going to see that you have your work plane here. So all your parameters are set, and this is the configuration that you have to work with. So anytime you're doing any design work, it's all going to be inside your machine's work area. So that's this space here. So next what we need to do is go into our workspace, and let's go ahead and open up our example cutout. So we're going to open up Hello World example, and we're going to select CNC Hello World. If you have a laser, drag knife, or plasma, you would select these options, and you should see the G-code start to generate here. And what we have is a path inside, which is our hello here. We have our CNC pocket, which is for the gear, and then of course our vector, which is the path outside. So you see how our vectors are showing the outside cut here. So that's precisely what we want. So we're going to go ahead and transfer this G-code to the OpenBuilds control. So now that we have our G-code sent over to the control software, what we need to do now is set up a 0 point for our machine. So the 0 point consists of a starting point basically for any project. So depending on where you've mounted your material, you need to set your 0 point on that left corner. So for us, we're just doing an air cut. So what I'm going to do is move my x-axis out slightly. I'm going to move my y back a couple millimeters, and I want to bring my z-axis down slightly as well. And the reason for doing so is this cut is going to basically simulate what an actual project cut would look like. So if you had your router and bit installed, it's basically going to work it just like any code. That being said, it's going to delve down and back up into the material. So I want to set my z-axis down slightly so it's not riding on the top portion of the actuator. So let's go ahead and set the 0 for X, Y, and Z. You'll see that our digital readout, 0 out here for X, Y, and Z. It's precisely what we want. And another feature I really want to show you is the check size feature, which is really cool. Now that we have our coordinates zeroed, let's go ahead and check the size. And this is a relatively small job, so you'll see that once we check the size. So you see we're kind of working with about 6 inches by 6 inches. So once again, we're going to go ahead and set that 0 point, and let's go ahead and run this job. Now if you have any issues, make sure to power off your machine or hit the stop job feature. It's immediate. So let's go ahead and run the job. And you'll see that I'm following here with the 3D viewer, and this is very accurate. It's in real time, so this is really cool. You can just follow your machine along. Okay, so you can see that this job has about 13 minutes left here, which is really cool. We also have a time here for each project that you're running. So based on that G-code that you've inputted, you'll see an estimated time here. So we're going to go ahead and stop this job here. You can either pause, stop, or the immediate stop. So we're going to go ahead and stop there, clear the alarm, and we're going to go ahead and run a homing cycle. Okay, so that concludes the wiring and software portion of this video. And as you can see, this machine came out great. Everything's wired up and everything's configured into your controller. Your machine's operating flawlessly. So now it's time to run some cool projects. So make sure to hit that like button, subscribe to the channel, and make sure to check out the OpenBuilds forum.